Hello students, in this lecture we continue the examples in the exercise 7.1. In the previous lectures we see the example number 1, 2, 3, 4 and 6. In this lecture we see the example number 5, 7 and 8. Okay. Now here the example number 5, find the probability distribution of number of successes in two tosses of a die. Here two tosses of the die. Then we know that the total outcomes in a two tosses of the die are the 36. Okay, here these are the total outcomes. Now here a success is defined as a number greater than 4 appear on at least one die. Here we want to find the probability distribution of the success, and success is a number is appear on at least one die is a greater than 4. A number greater than 4, that means it is a 5 or 6. That means highest number it is a 6, okay, and lowest it is a 1 on the die. Number greater than 4, that means 5 and 6. Now we want to count the numbers at least on the one die. It is a 5 or 6, that means the greater than 4, and it is a random variable. And now the random variable, it is a real valued function associated with each outcome. Here associate with each outcome of a sample space. Okay, it is a sample space. Here the total possibilities of the outcomes of in two tosses of a die, there are the 36 possibilities. We know that it. Now here there are the 36 outcome. That means here it is the first outcome, second, third, fourth, fifth, sixth. That is the 36 outcome. And random variable is a real valued function associated with each outcome. And now here random variable, it is here it is a number of total number, it is a 36. Now let x with a number greater than 4 appear on at least one die. Okay, here it is a x. Now x is a random variable. Now here we check in all outcome the number of the random variables. Here random variable, it is a number greater than 4 at least on a one die. Okay, at least on one die. Okay, here it is the first outcome, it is a 1 and 1. So there is a no 4 or no number greater than 4, that is 5 or 6. That means the random variable x takes value 0 for this outcome. Here it is a 0 because it is 1 3 and it is 1 4. It is also a number less than 4. We want to number greater than 4 on at least one die. Now here 1 comma 5, it is a 1 and 5. That means here it is a one number is a greater than 4. That means the value of x, here it is 1, here it is also 1. And now see carefully this. Here it is a 5 comma 5, it is a 5 comma 6. That means here 5 and 5, that means both numbers are greater than 4. Here both numbers are greater than 4. It is a both numbers are greater than 4. That means the random variable x takes value 0, 1 or 2. Okay, here it is a 0, here it is 1, and here it is a 2. Okay, random variable x takes values 0, 1 or 2. Therefore here random variable x takes values 0, 1 or 2. Okay. Now here we count the number of zeros 1 or 2. That means how many times the random variable takes the value 0, how many times the random variable takes value 1, how many times that random variable takes value 0. Okay. Now here see carefully this. Here it is a 0, 0, 0, 0. Here it is 1. Here it is 1. It is 1. Is also 1. It is 1. At least one die. It is 1. It is 1. But this is 2, 2, 2. But again here it is at least one die it shows number greater than 4. This is this and this. These are the two numbers. It is 1. It is 1. And here these 4 numbers, these 4 outcomes shows two numbers greater than 4. That means here when x is equal to 2, therefore number of x is equal to 2, it is a 4. When x is equal to 1, here it is 1. It is 1, 2, 3, 4, 8 and these 8, 16, and remaining 0, these are also 16. That means here we can write here the number of x is equal to 0, it is 16, and therefore probability of x is equal to 0, it is 16 upon 36. It is a probability. 0, here it is a 0, 0, 0, 0. Okay, and take the random variable, it is a 0. And x it is a number greater than 4. Here it is not on any one die, it is a number greater than 4. Now number of x is equal to 1, again it is a 16. Therefore probability of x is equal to 1, it is 16 upon 36. And the last, probability of x is equal to 2, that is a 4, and therefore probability of x is equal to 2, it is 4 upon 36. Okay, now we calculate this. Here it is 8 upon, it is a 4 by 9. Okay, here it is a 4 by 9, and here it is a 1 by 9, and it is a probabilities. Okay, now we write the probability distribution. Therefore probability distribution table. Of random variable x. Here x is a number greater than 4 appear on at least one die. Then here it is x. X takes value 0, 1, or it is a 2. Probability of x. When x is equal to 0, probability it is a 4 by 9. When x is equal to 1, probability it is a 4 by 9. And when x is equal to 2, probability it is a 1 by 9. And it is a probability distribution table of this random variable x. And x is a number greater than 4 appear on at least one die. Okay, see carefully this. Now we see the next example. Next, the example number 7. A coin is biased so that the head is 3 times as likely to occur as a tail. If the coin is tossed twice, if if a coin is tossed twice, find the probability distribution of number of tails. Now here two coins are tossed. A coin is tossed twice. Here a coin, here it is a coin is tossed. Therefore, the total outcomes are, it is HH, HT, TH, or it is a TT. These are the total outcomes. Therefore, number of yes, it is a 4. Now, here given that the probability of occurring the head and tail, here the head is a 3 times as like occur as a tail. Here given that the probability, given that the head is 3 times as like to occur as tail, that is probability of head, it is a 3/4, and probability of tail, it is a 1/4. Okay. Now we want to find the probability distribution of the number of tails. Okay, and here it is a total outcomes. When we count the number of tails in each outcome of a sample space, here the number of tails 0, here it is a number of tail 1, here it is a number of tail, it is 1, and it is a number of tail, it is a 0. That means 2. That means the random variable x takes value 0, 1 and 2. Okay, here 0, 1 and it is 2, because we want to count the number of tails. Okay, therefore let x be the number of tail when the coin tossed twice. Therefore, this random variable x takes values 0, 1 and 2. Okay. Here in the first outcome it is a 0, here 1, here 1 and it is a 2. Okay. Now we want to find the probability distribution of the number of tails. Okay. Now here see carefully. Therefore here we want to find the probability of x is equal to 0. X is equal to 0 means it is a probability of all heads. Here x is a number of tails, and here number of tails are a 0 when the outcome it is h, that is a both are the head, then number of tail it is a 0. Here when coin tossed twice, first outcome get head and the second outcome is also head. Here h and h, that is head and head, then and here it is a and, therefore by the principle of the multiplication, probability of h into probability of h, and then the probability of h it is a 3/4 into 3/4, and then it is 9/16. It is a probability of x is equal to 0. X it is a number of tails. Okay. Now the second probability of x is equal to 1, that means probability of when x is equal to 1, x is a number of tail, one tail there are the two possibilities, ht and it is a th. Okay. Here possibility it is ht or it is a th, that are the two possibilities. Here h and t or T and H. These are the two possibilities, HT or TH. That means here it is a H and T. Here it is a when coin toss twice, first get H and second get hit tail, or first get tail and second get head. That means here H and T or T and H are the two possibilities when the number of tails are 1. Okay, here it is a and in between it is a or. Therefore we can write, see carefully, it is a probability of H into probability of T plus probability of tail into probability of head. Okay, see carefully this, and then probability of H, it is a 3 by 4 into 1 by 4 plus 1 by 4 into 3 by 4, and then it is 4 by, sorry, it is a 3 by 16. 3 by 16 plus 3 by 16, that is 6 by 16, and then 6 by 16 we can write 3 by 8. Okay, see carefully this. Now last, probability of X is equal to 2. X, it is a number of tail, 2 tails. When we get 2 tails, when both are tail. Here first get tail and the second get tail. Therefore it is a probability of tail into probability of tail, and then it is 1 by 4 into 1 by 4, and that is 1 by 16. Okay, see carefully, and therefore the probability distribution of random variable X. Random variable X, it is the number of tails when 2 coins are the tossed. So a coin is tossed twice, then it is X, 0, 1, and it is 2. Then probability of X, when 0 it is a 9 by 16, when 1 it is a 3 by 8 or 6 by 16. Okay, and it is 1 by 16. It is a probability distribution table. Okay, see carefully this. Okay, see carefully, here the given the probability of head and is the probability of tail. Here the head is a 3 times as likely to occur than tail. Okay, then probability of yes, it is a 3 by 4, and probability of tail, it is a 1 by 4. Then the random variable X, it is a number of tails, and number of tails are, it is a 0, 1 or 2. When X is equal to 0, then the probability, when X is equal to 0, means both are the heads, and both are heads means first chance get head and the second chance is also get head. Here it is a multiplication, and here when X is equal to 1, means 1 tail, and there are the 2 possibilities. Here when get first chance it is a head and the second chance it is a tail, or first chance is a tail and second chance it is a head. Therefore there are the 2 possibilities, HT or it is a TH. Or so here we use the principle of the addition, and here it is H and T, T and H. Here we take the principle of the multiplication. It is a solution. See carefully. Now we see the next example. Now the example number 8. A random variable X has the following probability distribution. The following probability distribution. Here it is a random variable x. It is a 0, 1, 2, 3, 4, 5, 6, and it is a 7. Okay. Then the probability of random variable x, it is a 0, k, 2k, 2k, 3k, it is a k square, 2k square, 7k square plus k. Here it is a given probability distribution. Then determine number 1 the value of k, number 2 probability of x less than or equal to 3, and number 3 probability of x greater than 4. Now here see carefully. Here first we find the probability. So it is first we find the value of k. Here it is a probability mass function. Okay, and then we know that in the probability mass function the sum of the all probability is equal to 1. Here by using this condition we find the first value k, and then by using the cumulative distribution function we find the probability of x less than or equal to 3 and probability of x greater than 4. It is a probability of x less than 3 and it is a probability of x greater than 4. Now first we know that here we know that sum of the all probabilities, here I is equal to, here it is a 8. It is 1, 2, 3, 4, 5, 6, 7 and 8. Random, it is the probabilities are the 8. It is P1, P2, P3, P4. Then sum of the all probabilities is equal to 1, and therefore we can write 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square and plus 7k square plus k is equal to 1. Now we calculate this. First it is a square term, it is a k square 3k and it is a 10k square. 10k square. Now k plus 2k, it is 3k, 5k, 8k, it is a 9k plus 9k, and here it's equal to 1. We can write in this the left hand side, it is 1 minus 1 equal to 0. Now from this we get this quadratic equation. Now we solve this quadratic equation and get the value of the k. Then the multiplication it is a minus 10 and addition it is a plus 9. Okay, therefore 10k square plus 10k and minus k are the factors, and minus 1 is equal to 0. Therefore we can take common 10k, then we get here k plus 1, and here we take common minus k, therefore it is a k plus 1 is equal to 0. Okay, see carefully this. Then 10k minus 1 into k plus 1 is equal to 0. Then 10k minus 1 equal to 0 or k plus 1 is equal to 0, and therefore you can write k is equal to 1 by 10 or k is equal to minus 1. See carefully. Here k is equal to 1 by 10 or k is equal to minus 1, but here k it is a probability, and probability is a non-negative. Okay, when we take k is equal to minus 1, it is a minus 1, it is minus 2, it is minus 2. Okay, and probability it is a non-negative. Probability in between 0 and 1. 0 less than or equal to probability less than or equal to 1. It is a condition of the probability. Then here we cannot be take k is not equal to, k is equal to minus 1. Therefore here, but k is not equal to minus 1. Therefore we can write k is equal to 1 by 10. It is the value of k. It is our first question. Value of k. K is equal to 1 by 10. Now the second. Probability of x less than 3. Probability of x less than 3. Therefore it is a probability of x less than 3. X, the values of the x, 0, 1, 2, 3. Here it is a 3. X less than 3, that means 2, 1 and 0. Here x less than 3, that means x is equal to 2 or 1 or 0. Here x takes values 0 or 1 or 2 because x is a less than 3 and there is a or. So we take the addition in the probability. Therefore probability of x is equal to 0 plus probability of x is equal to 1 or the probability of x is equal to 2. X less than 3, x takes value 0, 1 or 2, then it is a probability, and then 0 plus k and plus 2k, and then it is a 3k, and 3k means 3 by 10. It is the answer of the second. Now third. Probability of x is a greater than 4. Here x is a greater than 4, that means greater than 4, 5, 6 or 7. Again here principle of the addition. Okay, cumulative distribution function. Probability of x is equal to 5 plus probability of x is equal to 6 plus probability of x is equal to 7, and then it is x is equal to 5. It is a k square plus 2k square plus 7k square plus k. Then the addition, it is 10k square plus k. It is addition 10k square plus k, and the value of k, it is 1 by 10. Therefore we can write, for the simple calculation we take k common. It is a 10k plus 1, k common, then it is a 1 by 10. It is a 10k, it is a 10 upon 10 plus 1, and then it is 10 upon 10, it is 1 plus 1, it is a 2, and then it is a 2 by 10, that means 1 by 5. It is a calculation. Here it is a 10 by 10, 10k, it is 10 by 10, it is 1 plus 1, 2, and it is 1 by 10, therefore 2 by 10, and it is 1 by 5. See carefully this, it is a cumulative distribution function. Here first we use the probability mass function, addition of the all probabilities is equal to 1. See carefully the calculation.